right. Kellen or someone, can you just confirm you can see my screen all right?
Yes, we can see it.
Okay, perfect. So as I said, I want to start just sharing a little bit about the technical report. So for the last 3 iterations of the National Climate Assessment, there's been a focused effort to take a look at the state of the sea level rise science and produce a sea level rise focused technical report that can inform that National Climate Assessment. And so right now, NCA 5 is underway. And so as a feeder piece to that, this interagency task force came together, representatives from Army Corps, NOAA, NASA, EPA, USGS, as well as some academic partners to do this sea level rise technical report. And the goal is really to provide the most up-to-date sea level rise projections for the country and serve as an input to NCA 5. And the data that's in this report is really intended to support sea level rise planning at multiple scales. So this report was a little bit different than the last couple of iterations because it included more information. So as before, sea level rise scenarios are a main feature of the technical report, and those are provided at global, US, regional, and local levels. And you can get that information for a specific tide gauge and also at a grid point, so really anywhere along the coast. And then the first new piece was extrapolated observations. And so this piece was taking the data that we have, both tide gauge data and satellite data, for the last 50 years and extrapolating it out the next 30 years. And so that gives us a really good idea about where we're headed in the near term. And then the other piece that's new is extreme water levels. And when we say extreme water levels, I think we think about the 100-year storm, right, or massive storm surge. But this is about all sorts of flooding events. So high tide flooding, things that you might have twice a year or a 10-year event, not just those really big incidences, but new information on the frequency of those high tide flooding events. And then for key takeaways from the technical report, you know, the big one is that we are seeing already an acceleration in the rate of rise out there. And we know that we're going to have 10 to 12 inches on average of sea level rise over the next 30 years. So by 2050, we'll have another foot of sea level rise to contend with. And that's the same amount of rise that we've experienced over the last 100 years. So that really illustrates the acceleration that we've seen. And we see that both in the tide gauge data and in the satellite altimetry data. I did want to flag, of course, that the rates of rise are very different around the country, depending on things like vertical land motion, as well as ocean currents in your area. I'm focused on work in the Gulf of Mexico, and as you all probably know, Louisiana has really high subsidence rates, so their rate of rise will be substantially higher than the average. It'll be far more than just a foot. And so what does this mean? It means that we'll have more extreme tides, and it means that when we do have a storm, that surge will go further inland. And then the other really key thing I think that is highlighted in the technical report is that we're looking at something of a regime change over the next 30 years, where a flood event that happens today pretty infrequently, but causes some significant damage, a moderate flooding event according to a NOAA threshold, that's going to be happening 10 times more frequently by 2050. So that really changes the game in terms of how we need to manage for high tide flooding. And then, of course, emissions are really important, right? And so what we're looking at is, 2 additional feet of sea level rise by the end of the century with just current emissions. And if we were to have rising emissions, then we could see some of those higher numbers, up to 7 feet by 2100. The other thing that's really a key takeaway, I think, from this report is that we have more certainty about what's going to happen in the next 30 years because the sea level rise science overall has gotten better. We have more observation data under our belt, and we can use that extrapolated observation as basically a second line of evidence that our scenarios are correct and in the right range. The uncertainty is greater as we get further out in time, right? And that's because we don't know what will happen with emissions and how global societies will decide to curtail emissions. And that really will influence which of the scenarios we're on after 2050. Good news is that we will get more certainty over time as we get more and more observations. So I pulled some of the data specific to California. I just picked 4 gauges up and down the coast, so you all could get a feel for some of the changes since the last report. And so I looked at intermediate low in 2080 and then intermediate high in 2080. And you can see the comparison between 2017 and 2022. And sort of the takeaway here, and I think the thing that has stood out for people the most is that the intermediate high scenario, as well as the high, those numbers have come down a little bit, and the trajectory or rate of acceleration is now thought to be a little bit slower, right? And that's good news, right? It means we have some more time. But those numbers have come down a bit. And then for California, the intermediate low has also, in most cases, come down a little bit. Here in the Gulf, where I am, those numbers have actually come up a little bit. And so overall, across the country, we really see a narrowing of the range across scenarios. And that's good news, right? In that it means we have more certainty about what's possible. And just a little bit about where you can find all of this. And I really appreciate Kellen already put a link in there to the technical report. And if you go to the landing page, you can get access to the report itself. There's a set of FAQs, which are really basic explanations of some of the concepts in the technical report. There's a podcast interview with some of the authors, and then you can also get access to data and tools. In terms of data, there's access to the raw tables, right? If you want to import that into a tool or something that you're working with, you can grab it. And there's also an API, which I am not a technical person, but my understanding is that that just makes it a lot easier to absorb the data into a GIS tool, for example. And then there are some existing tools out there that many of you are probably familiar with. The Sea Level Rise Viewer from NOAA is a tool that I know folks have been using to look at what sea level rise might mean for their place. And we did incorporate the 2022 scenarios into that tool. We realized that the 2017 scenarios are still being used by a lot of folks, so those are in there too. If you go to the viewer and you go to the local scenarios, you can choose whether you want to see the 2017 or the 2022 information and do some compare and contrast for your location. NASA has a great tool that they developed that also shares up the data from the tech report. And I go to the NASA tool when I want to think about the different contributions to sea level rise, because they have some great graphics that show you what vertical land motion is contributing, what ocean processes are contributing, and then how ice sheets are contributing. And you can see over time how at the moment, vertical land motion is really important to those differences. But as we get further out and we get to 2090 or 2100, it's the ice sheets that are really going to determine which of the scenarios we're tracking on. We also have a tool, Adapting Stormwater Management for Coastal Floods. That's really for folks who are thinking about, what's the threshold at which we're going to start to have problems, right? When are our backflow area or our outflows going to start to have salt water coming up them? Or when is my seawall going to be topped over? And so this is a tool where you can plug in your local threshold and get some information about when it's likely to be crossed. And then finally, there's a coastal county snapshot, which just provides sort of county scale, a quick look at how sea level rise is going to impact things like businesses. So those are some tools that are out there that have already incorporated the 2022 information, and there'll be more to come, I'm sure. All right, so that's the tech report. And I want to switch over now and talk about the application guide. So the last time we had a technical report, which is 2017, there was great information in there, but it wasn't super accessible for land use planners and floodplain managers and public works folks and local county commissioners. And so it took a couple of years for Sea Grant extension agents, folks from NOAA, and others really trying to do on the ground translation of the science. It took a couple years for that information to start to get applied. And this time around, we really wanted to try and fast track that process and have a companion piece as soon as possible that would help folks know what's in the new technical report and think about how do I apply that to my situation and to my community. And it was really a really great process to be part of because we really had a coalition of the willing of science translators, extension agents, boundary spanner types that were interested in this and came together and did this application guide, on the side. There was no funding for this. It was just something that folks felt strongly we needed to do. And so we came together to make it happen. And on the phone today, Laura Engman from California Sea Grant and Scripps is on the line, and she was one of the authors as well. And we tried really hard to make sure that we had representation from all across the country. And so we had my colleague Jamie from Maine, we had Renee from the Northern Gulf, we had Katie from Hawaii, we had Ian from Washington, we had Jill from Georgia. So we really had a nice distribution of folks from around the country, which was very helpful because in the course of working on the guide, we would hear about how different terms are understood or used in different ways in different places. And that would flag for us that we had to be really careful with our terminology and perhaps shift up the words that we're using to talk about things. So the guide is not sort of a manual, right? It's not going to give step-by-step instructions or serve as engineering guidance, right, for a community or for a local planner. But it really should help someone figure out how they can use the new sea level rise data and what it means for their community. And it can help you think through about which planning approach you might want to take. I'll get into some detail about those planning approaches, but we work through some of the different ways that communities have been planning for sea level rise and talk about how the scenarios can be used for those different approaches. So the application guide starts out, the first chunk is really just explaining things, right? What's in the tech report, defining terms, helping people understand the new information and what changed from 2017. So that's sort of the first chunk. And then the second chunk is talking about, okay, how do I apply it and use it in these different planning approaches? And I'll touch on each of the three main planning approaches that we address. So the first part, the explainer part, speaks to those three components that I mentioned. So the tech report had the projections, the extrapolated observations, and then this extreme water level information. And so we did just some basic science translation of what those things all mean and introduced the new concepts that are different from the 2017 report and just provided some basic descriptions that folks can use and then turn around and share, right, in their communities to help folks understand what's in the report. So touching on what changed since 2017, that's one of the first questions that folks who are already nerding out on sea level rise want to know. So I will note that the extreme sea level rise scenario has been removed. And that's because the latest sea level rise science and namely the ice sheet science suggests that that's not a probable outcome, right, by the end of the century. And so the extreme scenario has been removed. It's still possible that we could see a range up to 2 meters by 2100. And so the endpoints haven't changed, but the rate of rise and acceleration over the course of the century is slower. And there's been a narrowing, right? So there's as I said, when I showed the California gauges, there's just a narrower range of what's possible, particularly in the near term, because we have more certainty. So that's really good news. Touching on the observation-based extrapolations. So this is only available at tide gauges because it does rely on data from those gauges as well as the satellite data. But what the authors did is that they took the observation data we have from 1970 to today, and then they just extrapolated it out, what that would look like. And because we already have seen in the data that the rate of rise is accelerating, that extrapolated obs carries that on, and you see that rate of rise. But it's as I said, it's sort of another line of evidence for us that, and you'll see if you look at the extrapolated observations across the country, they align around the intermediate low scenario. So it's just another line of evidence that suggests that we are seeing that rate of rise and we know what we're going to have in the next 30 years or so. And because it's based on the tide gauges, it does include your local processes that are happening, such as vertical land motion that varies around the country. And then the other new piece is this extreme water level analysis. And it does speak to the frequencies of a range of different flooding events. So your 100-year event is not the only thing addressed here. It's also talking about those floods that you might have, every 25 years, every 10 years, and then those high tide floods that happen a couple times a year. It speaks to all of those. And so it helps you understand the frequency with which those floods are going to be occurring. And also if you have a certain return frequency that you're planning for, like if you're building a building for the 25-year flood, you can figure out what the magnitude of that and how it will change. And I'm going to show a graphic in a minute, which really helps understand all of this. But again, the takeaway from the extreme water level information is that we're going to see that regime shift where that moderate flooding that we have, pretty rarely right now, that's going to be occurring on a regular basis in our communities. So this is the graphic, and it is a lot to get your brain around. And I have to give credit to my colleague, Jamie Carter, with OCM, because he put this together and it really, really helped, I think, all of us understand what the extreme water level information means and what the implications are. And I'm just going to speak briefly to sort of the three different things that you can see here in this graphic. It's the A, B, and C. And so for A, you can see that a 10% annual chance water level from 1992, right, is going to be occurring once or twice a year by the time we get to 2050, right? So something that only had a 1 in 10 chance is going to start to be happening more frequently. And then B, you can see that a moderate flood, that's the orange dashed line, the red, orange, and yellow are the major, moderate, minor. And you can see how that moderate flood event will be occurring more frequently, and in fact, 18 times more frequently in 2050 than it was in 1992. And then finally, just like I was saying about if you're designing to a specific flood elevation, say the 25-year event, that's what part C shows us, is that designing for a 25-year event is going to be 9.6 feet NAVD 88 by the time we get to 2050. So, higher than it was in 1992. So it's a lot, but I did want to mention extreme water levels because I think there's a lot of potential for this information to inform design, right? Of everything from stormwater outfalls to new construction, to roads and all the rest of it. So it is really an important piece. There is a section of the application guide that speaks to datums and talks through what are terrestrial datums, what are tidal datums, and how do you look at things across different datums, and also speaks to the reference point or start year for different scenarios, which is really important and has come up for a lot of us and when we're trying to talk about sea level rise. And just offers some tips, right, for how you can work across datums. And if you have data with different baseline years, how do you handle that? So it's just basic advice. Okay, I wanted to talk now about the 3 big approaches for planning that we used in the application guide. And I think these 3 approaches are ones that many of you will be familiar with. Some of you were probably already applying these approaches, but it was really helpful as a framework to talk through how you could use sea level rise information in planning and really deal with the uncertainty that we are facing since we don't know what will happen with emissions. So these are the 3 approaches we talked through: risk tolerance, scenario planning, and then adaptation pathways. And so risk tolerance is thinking about your project or activity that you're designing and thinking about whether you have a high tolerance for risk, which means that you might be okay using a lower sea level rise scenario. Because it's not the end of the world, right? If it turns out that it's higher than that. But if you have something you're planning where you have a very low tolerance for risk, like it's a really critical piece of infrastructure that is going to serve a lot of people and needs to be around for a long time, you've got a pretty low risk tolerance. So you might want to go with a higher sea level rise scenario. This is not a great approach for dynamic environments, beaches and dunes that are shifting all the time. And some aspects of restoration, this probably doesn't work well for. A little bit more detail about using scenarios. These are the global scenarios, but just reminder that, this is the range of what's scientifically possible by the end of the century. And then the other thing that we think about when we think about risk tolerance is, what are the exceedance probabilities? And so what are the chances that we're going to have more sea level rise than what those scenarios, each of them shows, under different emission scenarios? And this is a table that shows up in the technical report and app guide that shows what the exceedance probabilities are for a 1.5 degree rise in temperature, a 3 degree Celsius rise, and a 5 degree. And you can see that if we have, 1.5 degrees Celsius increase, there's a pretty high probability that we're going to be exceeding that low scenario, right? And there's a decent probability that we'll be exceeding the intermediate low as well. The probabilities of exceeding those higher scenarios are still very low. However, the last piece of this table is just a reminder that if we were to have, high emissions and some of those low confidence processes, and that's really the ice sheet melt that we're talking about there, there is a possibility, right, that we could exceed some of those higher scenarios. But this helps us think too about our risk tolerance. And so some factors to think about if you are taking a risk tolerance approach is just, how big is your project? How expensive is it, right? How much are you spending and what's the value of the work? And is it critical, right? How many people does it serve? What happens if it were to go down, right? Thinking through those things. How long do you need the asset to last? And then also how adaptable is it, right? If it turns out that we end up on a higher scenario. And the example that one of my Sea Grant colleagues here in Florida uses a lot is that, if you're building a new nuclear power plant, right, we're thinking about trying to protect the Turkey Point plant south of Miami, you have a really low risk tolerance, right? So you're going to want to use a higher scenario. But if you're building a backyard shed that you only think it's going to last for 10 years anyway, then you might have a pretty high risk tolerance and use a lower scenario. All right, turning to scenario planning. This is an approach for planning that is good when you have a complex situation and you want to look at multiple variables. It's something that is used a fair amount in natural resource management. It's not great if you have a super simple situation where you know for sure that you have a high risk tolerance or a low risk tolerance. But for those more complex situations, it's going to help you explore the plausible futures. It'll help you think through, okay, what are the outcomes under different scenarios and under different management actions? And it helps you identify those actions that will perform well no matter what plays out. And so this is an example just to illustrate, and this is a really basic one, right? Because when you do scenario planning, you're probably thinking about lots of things in terms of what might happen, not just with sea level rise, but also with communities and people and development patterns. And so this is looking at, if you were thinking through, okay, what could happen with sea level rise and with land use change? And you see up at the top, here's the different scenarios, right? You could have a lot of sea level rise, but not very much land use change, not a lot of new development. Or over on the right, you could have not so much sea level rise and not much land use change. But then also you could have a lot of sea level rise and a lot of land use change. So 4 different possible scenarios. And then management strategies are different things that you might do to plan for these different scenarios. And then you can assign a score to how those different management strategies are going to perform, right? And this is just an illustrative example, but looking at this, you can see that the second management strategy is one that's going to perform the best across all of the scenarios, right? It'll do at least reasonably well across the scenarios. So that might be the one that you would pick. And then the final planning approach that we work through in the guide is adaptation pathways. And this is one that I know is being applied in California. And then also there's some good work going on in Maine. And this is something that I think the natural resource management community has been ahead on and doing more of. And now some of the built environment community planning folks are starting to use it as well. And this is a good approach when things are changing and shifting, and also when you don't have a huge budget, right? And so you need to do some things now, but you recognize that you'll be needing to take additional action later on as things progress. This is not a great approach if you can't further adapt along the line, if you have low adaptive capacity, and if there's lots of drivers of change. And this graphic just helps illustrate the concept, right? So if you don't have a big budget right now, you might start out with strategy A, which helps you up until you have a ½ foot of sea level rise. But once you get to that threshold, you're going to have to do more and invest more to protect your community or your project or whatever it is. And one of the examples that I know has been talked about in California some is that the Department of Transportation, right, is thinking about some parts of the coastal highway where in the short term, they can do some natural living shoreline type work, build some dunes, protect the road. But over time, ultimately, there'll probably be a need to move the road back, right? And so that might be your strategy B or C that you take when you hit a certain threshold. And so in closing, I just want to share that, I think the pairing of the technical report, which has all the detailed science and the equations for all the modelers to geek out on, having that paired with this application guide piece that really explains things and helps translate it to a planning context was really a nice model. And I'm hoping that this is something that the federal science family will continue to do. And I'm really grateful for Laura and others around the country who work for Sea Grant and the coastal training programs at the research reserves who came together to make this happen. And I hope we'll be doing a lot more of it. And with that, I think we can turn it to questions and I will stop sharing. So you can see. And I can always go back to a slide too if we need to.
Great, thank you so much, Heidi. That was an amazing presentation. I love that there was a need for, you all saw a need for the application guide. We're just gonna do it. I can see the huge benefit from it. So we're gonna wait for some questions to pop in. Please remember everyone to put your questions in the Q&A box. It's on the bottom kind of right-hand side of your Zoom screen.
And I will say that we, when we did this, we weren't sure, how people would respond to it. But the app guide has gotten a great response and interest from really diverse communities. I was at a meeting in Savannah recently, and the planner from Tybee Island, he brought a hard copy with him. And so he's using it as he thinks about how Tybee Island can plan. And then there was some communication with the National Realtors Association, and their environmental committee was interested in the app guide and sharing it around. So diverse user base, which is exciting. That's what we really were hoping for. There must be questions.
Maybe you did such a good job explaining it. Everyone's just like, that's it. We're just so pumped to go use this in our communities and on our projects.
And I will say that as you are using the guide, we would love to hear about it, right? And my colleagues on the West Coast, Becky Lundy and Becky Smythe, I think they're on the line today. They'd love to know about examples. And then I'm interested too, and we can provide additional technical assistance if needed, right? If there's a graphic in the guide that you think is great and you'd really like to have that tailored to your place, feel free to reach out, or if you want to talk through anything that's in there, we can do that as well.
Yeah, these are good comments. We got a couple in the chat just that it's taking some time to digest it, and it would be great to have a place to send questions afterwards. So would your email be the right place to send questions afterwards, Heidi?
I just put it in the chat. Yep. Feel free to email me for sure.
Great. I just have a random question. Did these reports come out? I know you were talking about the 2017 technical report that came out, and this one was in 2022. Do they regularly come out every 5 years? Or is that the planned schedule? Or when can we expect? I know it just came out, but when's the next one going to be in the works?
Yeah, so it has been a regular cadence of about 5 years because it's been designed to support the National Climate Assessment. And so in likelihood, yes, we'll try and do another technical report before NCA 6, right? And I should have mentioned this up front too. It is also drawing on the IPCC process. And so the International Panel on Climate Change, they put out their latest report, which is, the shorthand is AR6, right? And the data in that did inform this technical report. And so there's always that interplay with IPCC as well.
Okay, cool.
All right, I see a question from Becky about how to incorporate the new numbers when there's existing guidance. And I think that this is something that places around the country are grappling with and sort of need to make the decision, right, about what makes sense for them. And I know we had some good conversation with folks in Southeast Florida, so the Miami, Fort Lauderdale, Broward area, because they are already applying scenarios, right, to their planning work down there. And they have big investments underway based on those scenarios. And so we had a conversation with them, and they ultimately decided that because the scenarios they're using are still within the range of what's possible, right, under the 2022 report, that they would stick with what they have at this point and keep going. But the state of Florida as a whole, right, has incorporated the 2017 scenarios in some of their regulatory pieces and what local governments are required to do. And they're evaluating it and thinking about whether they want to update to 2022 they're doing some Florida specific analysis to try and figure that out. So I don't think there's a one size fits all for how to address that. And I think it also reminds me about the risk tolerance piece, right? And so if you were using a 2017 projection of intermediate high, and now you see that in 2022, it's a little bit lower, but you still, it's a really low risk tolerance situation, like you're building a hospital or a wastewater treatment plant. Go ahead and stick with the higher number, right? There's no problem with that. Where it gets more complicated is this with natural resources and restoration projects, right? Because if you're restoring a wetland and you build it super high to plan for a whole bunch of sea level rise, then it doesn't have the same functionality that you need to have as for a wetland, right? And so there you might decide, okay, yeah, this new information means we should use a slightly lower elevation for that marsh. I'll ask Laura maybe to weigh in here too, because I'm sure she has thoughts specific to California.
Sure. I mean, I think a lot of our cities and jurisdictions have done at least vulnerability assessments, and those have looked at a wide range of scenarios. So, you know, the current projections will generally fit in those scenarios. And so you're still able to sort of look at different levels of sea level rise and understanding sort of what infrastructure, roads, or communities or natural resources might be impacted at those levels. What might change is at what point in time is that more likely to happen. So I think the likelihood of when it might happen within the time range is something to consider in terms of then as you move from just understanding your sea level rise risk to actually planning adaptation projects and what you're trying to achieve in that near term time frame, so up to the 2050 mark, or then you've got that kind of intermediate time frame where we still have more certainty in the new sea level rise science, but a little bit less than what we, up to 2050, we have a lot more certainty. So I think feeling good about we're planning and your planning horizons and what you're using in that space, and then going out to 2050, start being a little bit flexible about the range, what's within the range of the current and updated 2022 scenarios. And then understanding that the end of the century, you know, is where the most uncertainty is, and the extreme was taken out. However, you know, we're not planning a lot of things for out to that century, but there is still a question mark as to if there are low confidence processes or ice cliff instability, it's most likely to happen after that 2100. But it's not to say that it won't happen. It's just that the timing of when it might happen, in addition to if and when we reach those global warming levels. So there's a lot to be said about having all of those things stack up and understanding what that risk is and what kind of decisions even relate to understanding that risk at such a time frame so far out. I think the other piece I'll just mention is that Justine and I think maybe Ella from the Ocean Protection Council are on here today, and the Ocean Protection Council has initiated an update of their sea level rise report and guidance, and myself and a number of other folks are on a task force, are currently working at ways that we can incorporate this new information that you heard Heidi talk about in terms of new sea level rise scenarios, high tide flooding frequency, and where sort of our tide gauges say we have been and where we're going, all of this into a new report that will be out sometime in 2023, most likely.
Thanks, Laura. Really appreciate that. We do have some questions that came in the Q&A. So I'm going to try and speak a little bit to those. Somebody had asked about how and why the extreme scenario was dropped. And that really is all about the latest science about the ice sheets and the potential for there to be rapid loss and melt of those sheets. And the probabilities now of that are just so low that it didn't make sense to include that extreme scenario anymore. So that's why that was removed. There's a question also about whether the future extreme water levels will be incorporated into FEMA-based flood elevations or flood insurance rate maps. And that one is a little bit harder to answer, because I think the answer is no, in that FEMA is not specifically taking that data and trying to incorporate it in the flood insurance rate maps. However, there is a process underway as part of implementing the federal flood risk management standard, which is a standard that requires investments using federal funds to plan for future flooding, specifically sea level rise. And that regulation is something that is being developed right now. And the agencies like HUD and FEMA are writing their regs for how that will be incorporated into their requirements. So if you get FEMA money or if you get HUD money, you will need to think about sea level rise and incorporate that into your designs. And as part of that whole process, FEMA will be developing maps that add 1 to 3 feet of sea level rise to what's currently in those flood insurance rate maps. So there is work underway. I don't want to imply that there isn't work underway about considering sea level rise, because FEMA is working on that, and they're going to be building a map library for that. But it isn't specifically incorporating the return frequencies of high tide flooding. And then Ian had a question. Let me come back to that one. I think Ian's question is one that we have to turn to the group, because Ian was wondering about whether that slightly lower 2050 magnitudes compared to 2017, has that proven important anywhere? And is that really changing what somebody's doing somewhere? And I would love to hear about it if anyone does have any examples of that. I do think that it has the potential to inform somebody who's working on a restoration project, perhaps, but I haven't heard any specific examples. So if anybody has any, would love to hear.
I haven't heard yet, but I also think that the new projections are still not quite hitting, they haven't quite hit the ground as far as some projects go. So I anticipate that may come up, but not, I haven't heard about it yet, specific an example yet.
I threw a couple links in the chat for the sea level rise viewer, and that is the place to go if you want to see the inundation on a map, right? And you can zoom in to find, you know, your community or your part of town, and then visualize what different amounts of sea level rise will look like, what will be inundated. And there's a section in there where you can find the scenarios for both 2017 and 2022. And I will mention that right now you have to look at flooding in 1 foot increments. So you can look at 1, 2, 3 feet, etc. But we're going to be adding half-foot layers in there. So you'll be able to look at 1.5 feet or 2.5 feet. So that's going to be coming in the coming year. And then the other tool I put in there is the NASA tool. And that's a great place to go if you want to look at the different contributions, like what are the ice sheets doing and how much of this is vertical land motion. And it's also a place where you can see the extrapolated observation number for a tide gauge. We will be adding that extrapolated observation information to the viewer in the coming year as well. So more to come.
Amazing. Thank you again so much, Heidi, and thank you, Laura and Justine, for being here to answer questions as well. I'm seeing a little pause in questions, so we can end it. Otherwise, unless we just want to sit here and look at each other for a little while longer. Thank you all so much for coming. I am putting in a link for the California Coastal Resilience Network webpage. There is a link there if you are interested in signing up for our updates, email updates if you aren't already on our list, and be expecting a follow-up email from me next week with the slides and the webinar recording as well. Thank you again so much for being here, Heidi, and for all the information, and thanks everyone for attending. Have a great day.
Thank you, Heidi.